This video shows expert active learning instruction with commentary from the instructor that reveals the thinking behind the teaching. I will cue you to take the time to reflect on what you noticed before hearing from the instructor. In this video, you will see the instructor interact with a few different groups of students. As you watch these interactions, consider this question, which we will return to later. What are the instructor's goals as he interacts with students?
First thing we're going to look at, epistasis. So epistasis describes an interaction basically between genes where one gene can influence another gene. All of the situations we've looked at so far, be it one single gene situations or even where there have been multiple genes, those genes really had nothing to do with each other. Epistasis is a little bit different situation where one gene can influence the phenotype that results from another gene. And there's a lot of different ways that a gene can impact another gene. So epistasis can take many different forms. We're just going to get to look at one kind of classic example where one gene can interfere with or block the expression of another.
The three colors of Labrador retrievers, black, brown, and yellow, result from an epistatic interaction. One gene codes for a protein that is needed to produce the pigment, and black pigment is dominant to the chocolate brown. Another gene encodes a protein involved in depositing the pigment into hair follicles, and pigment is dominant to no pigment. With that background in mind, the instructor asks students to answer the following question. Pause the video to read the question. You may also want to solve the question before you watch the instructor discuss it with students. The correct answer is D. We will now turn our attention back to the classroom, where students have just started working on this question in small groups.
Good morning. How are we doing?
Good.
What we got so far?
I kind of figured out, I think, that you can't do A or C because since there's two lowercase e's, they can cross with each other and make a yellow lab.
Okay. So you got it down to B and D, possibly? Okay. Where are you going to go from there?
Well, I'm just writing out the possibilities for the yellow and the black, and then see
Okay.
which could go.
All right, we'll continue on. Don't let me interfere.
Thank you.
What do we got so far?
So we canceled A and B because those aren't yellow or chocolate parents. And
Based on the phenotype of the parents? Okay, yeah.
And then I canceled C because they don't have any yellow offspring. But if you do C, it'll give you yellow offspring, and
Okay.
D won't give you yellow offspring because the capital E will always be with the lowercase e. So you'll never have a double lowercase e.
Okay.
So D.
So D would be the...
Mm-hmm.
So based on kind of process of elimination? Mm-hmm. Okay. Right on. Good morning.
Good morning.
What we got so far? Ooh, what's that?
Punnett square.
That's so much color.
So,
I'm thinking
it's
that
very easy for my brain.
it could be either B or D. I don't understand why it would be strictly one or the other.
Why are you choosing B or D based on what?
Because they both have a little b, so you would need that to match up. So that would give you at least one little b. And
Okay.
then it has to have or I'm assuming that because there were no yellow offspring, you wouldn't match up two little b's. So the double dominant capital E's
Okay.
would match up also.
Okay. So you're saying B or D could kind of get you that offspring combination? Okay. So how What other info could we use maybe for those two?
Well, I'd say the ratio, but it's like that's just random. So you don't.
Yep, so you use the ratio there to kind of figure out B or D. You also know, though, that the parents, one's yellow and one's chocolate.
Oh,
So,
yeah, I totally forgot about that.
That's
part.
important info, too, so.
Thank you.
What are the instructor's goals as he interacts with students? Pause here to write down your ideas. Now let's hear the instructor share the thinking behind their teaching, and particularly what would be lost if he didn't interact with groups as they worked on questions.
I wouldn't get a chance to really get to know them at all. I wouldn't get a feel for what they're thinking. I wouldn't get a feel for their confidence level. Just because, say, 75% of the class gets a particular question right doesn't mean they got it right for the right reason necessarily, and doesn't give you a feel for how confident they would be if you gave them a similar situation, but one that's a little different. Like, you don't get a feel for any of that kind of stuff just from how they answer a question. So that's kind of the goal, is to just get a better idea of what's going on in the classroom.
Next, let's hear from Dr. Dees about the thinking behind the specific ways in which he interacts with students as they work.
I very rarely will confirm or deny an answer with these interactions. I'm mostly trying to get them to clarify their thinking, whether they're right or wrong. If they're going down the wrong path, I'll normally kind of nudge them in another direction. And even if they're right, most of the time I won't even necessarily confirm that they're right until, after the whole class answers. I'm mostly looking for what are the students' reasoning and get them to explain why did you do what you did.
One goal Dr. Dees has for his interactions with students is to create opportunities for them to explain why they did what they did. What benefits does this have for students? Pause now to jot down some ideas. Let's hear the thinking behind Dr. Dees' teaching.
Well, it's one of the opportunities we have in a big class. With so many students, we don't have a lot of writing opportunities, things where you get a chance to write out your thinking. We do group review worksheets later on. Next week we'll do that before the test, but this is more of just a verbal, try to get them to explain what they're thinking and why. And it helps me both to learn what students' reasoning is. One of the things that's very common that you see in intro bio is sort of algorithmic thinking, learning how to solve a problem and not necessarily why. And that leads to issues later on with exams and things where you're expected to demonstrate, that you understand the material. But if you take the approach of, I see this, I do that. I see that situation, I do that, but I don't really understand why I'm doing what I'm doing. I'm just kind of an algorithm. That's where you get issues later on. So it's really helpful to get students to explain why are you doing what you're doing.
Dr. Dees has explained that one goal he has during small group interactions is to learn what his students are thinking. What could you imagine the instructor doing with information gleaned from hearing students' reasoning? Pause and write down 3 ideas.
So it's helpful in a lot of ways. Some of it is just like just-in-time teaching kind of thing. If I ask a question and a lot of groups are having kind of similar issues with it or taking an unexpected approach or things like that, I can address that right there, on the spot. Or I could think about it for the next class maybe where I would come back. I had a situation earlier in the semester where there was a question about meiosis during the class and it didn't go very well at all. So the next class, the first thing we did was another question on the similar things. I can react like in either real time or shortly thereafter to something that's going on in the class. And then also for assessments later on, if you're in these conversations, if you're identifying certain issues, that can help you design assessment questions too.
To summarize, for this expert active learning instructor, hearing students thinking during class is a crucial part of teaching. He uses what he learns about his students to inform his teaching in the moment and in the future. 3 key actions he takes are asking questions that require more than algorithmic solutions, walking around and talking to students, and refraining from giving or confirming answers. Now that you've had a chance to see the thinking behind the teaching for this instructor, reflect on your own teaching. Do you interact with students while they work? If not, what might you gain from inviting a few students to share their reasonings with you as they work? If you already interact with students while they work, what new ideas or insights from this video could you bring into your own interactions with students? Take a minute to write down one thing you'd like to try in your teaching. In the spirit of considering the thinking behind the teaching, explain why you'd like to make this change.